So, hi everyone, I'm Thomas Vincent. I work with Andy at ESRF, and I was initially in the data analysis unit, so more on the reading side and the writing side of hdf5. And initially, we had some detectors that were providing compressed data with a third-party plugin of hdf5. And we wanted to make that easy for the users to install this plugin from Python, because we promote Python as a data analysis language. And yeah, better. And so we started packaging some hdf5 compression filters to be usable from Python. So initially it was LZ4 and bitshuffle, and only for reading, and as it goes, we started to add more, find a way to also provide writing, and this is what I will present you today. So let's look at a small hdf5 file with 3 datasets, and we'll look at the first one, which is compressed, and the last one, which is not. So I use a small tool from European XFED developed by Thomas Kluwer called h5glance, which allow easy browsing of hdf5 files from notebook and from the command line without visualization, but allow to browse the structure. So from h5py, for those who don't know, to open a file, you do it this way. You open the file here in read mode. I access the dataset, and here it's to extract the whole data, and I'm showing it. So here I have a nice image of 2D data. And if I try to access the compressed data, I get an error because the compression filter is not accessible by default. So can't read data. It tries to load some plugins, but it's a local installation. It's not system-wise, and there is no plugin on the system. Okay, that's where you want to use hdf5 plugin. And to read data, all you have to do is to install well, h5py obviously, and then install hdf5 plugin and import it. So to install, it's available in the main Python packaging channels, pip and conda. And once you import, better this way. Okay, once you import hdf5 plugin, if I try to access again the file, hdf5 plugin has loaded the compression filter in libhdf5 used by h5py, and I can access my data. So it's pretty transparent, except for the import to read data. Okay, let's close the file now. And if I want to write compressed datasets, it will be a bit more involved because you need to pass some parameter to the compression. But let's see. So again, small snippet of code for h5py for writing a dataset. So I open the file in write mode here, create a new file. I create a dataset with this method, create dataset. Now here is an example of what you should write to write a compressed dataset. So the same, I call create dataset, and I pass some parameters for the compression. So the compression filter ID here, which say which filter I want to use, and some parameters. So here this ID is for the blosc filter that you will hear about blosc in the next talk. And you have to pass some option as integers, so you really have to know what you want to pass. So that's not really user-friendly. So what we added in a hdf5 plugin is for the filter we provide. We also provide some small helpers that allow to write a human-readable configuration of the plugin. So here it's for blosc, and it's the same configuration as here. I want to use with blosc with the LZ4 compression, with compression level number 5 that you see here, and with bit shuffling. So you have bit shuffling is basically taking a window of many values and taking the first bits of each value, putting them together, then taking the second bit, putting them together. And by interleaving data this way, if you have lots of small values, you expect to have a lot of zeros for the high bits packed together, and then the compression works much better. So you have two shuffling, bit by bit, or byte shuffling, where you take 8 bits by 8 bits and do the same. And you get some documentation, so you can more easily use the compression this way. So, well, okay. So here what the file I've written. And if I list the file, I have here the file 3.4 megabyte with blosc and 3.7. So it's not compressing well this kind of data, but I get some compression between the uncompressed file and the compressed file. So that's about it for the API of hdf5plugin, which has thin layer to make things easier to use with h5py. And let's make a tour of the different compression filters that are embedded into hdf5plugin and into libhdf5 and h5py in general. So first of all, what you get from Python usually is what is inside libhdf5. So gzip is there by default, and szip can be there optionally. I think it's due to license constraints. And h5py provide LZF, that is another compression filter that is embedded inside h5py. And finally, you get some byte shuffling pre-compression filter available in h5py, in libhdf5. So that's compression equal gzip, shuffle equal throw. That's just a code snippet to use those that are available by default. And so with hdf5 plugin, we add 6 compression filters out of the 28 of the hdf5 filter zoo. And so it's bitshuffle, blosc, FCIDECOMP, LZ4, ZFP, and Zstandard that I will detail a bit more now. So first, what I call general purpose, they don't take assumption on the kind of data or the dimensionality of the data. They can compress anything. So bitshuffle first, it's both bit shuffling filter and LZ4 filter all at once, because it works on a small window of data that fits into the CPU cache, and they do both operation of bit shuffling and compression one after the other to be more efficient. LZ4 only, Zstandard, and blosc. So blosc is not a compressor in itself, but it provides access to many compression algorithms with a unique API. And so byte shuffling and bit shuffling as a pre-compression filter. And it uses the same approach as bitshuffle to use a small window of data to efficiently use the CPU cache. And so through blosc, you get 6 compression libraries that you can use with one API. And so if we do a comparison with blosc and the other, actually blosc provides all the features that the other unique filter provides. So bitshuffle you can do the same with blosc, LZ4 same, the Zstandard same, and the hdf5 shuffling as well. So there is really an equivalence between the generic one providing many and all the single filters providing one compression at a time. We have included 2 more compression filters that are more specific because like FCIDECOMP works on images basically, so the chunk needs to be 2D or 3D with 4 channels, means RGBA kind of things. And the ZFP, which is a lossy compression, does not work on all kind of data, and dimensionality is limited to up to 4D of the chunks, but it leverages the correlation of the data in multiple dimensions, up to 4D. And you can control the loss of precision in different ways. So either you fix bit rate, or you say, I want absolute or relative precision, that you can set a threshold of what is kept. So just a quick look at performances on one cases. So I'm running this from a shared memory with a dataset, which is about 800 megabytes of tomography data. So it's just running on one thread. And big enough, maybe. Okay, so that this kind of data, lots of very small values and a few parts with high spots and high values. And here is all the filters. So you have lots of blosc because it provides lots of options. So at the bottom, you have raw access without compression. Here you have gzip, which is the default, about 7 compression. And at the top, you have bitshuffle and Zstandard, which provide up to 10 compression factor. And what we are interested in is a good trade-off between speed and compression rate, and it's about here. And there is no surprise why Dectris using bitshuffle here. You have high speed and still between 7.5 and 8 compression ratio. And we see that with one thread, blosc, LZ4 bitshuffle, and bitshuffle, which are the equivalent, gives similar results in terms of speed and compression rate. So in terms of multi-threaded, not all filters support multi-threading, but blosc provide it as using a pool of threads that you can configure with an environment variable. And the bitshuffle and LZ4 filter, they are using OpenMP to provide multi-threaded decompression. And you have to enable it at compile time, and then you can control it with the OpenMP num thread that you can set to limit the number of threads that it's using. So in summary, to me, it's important to provide different trade-offs between compression speed and compression rate, and to accommodate with different kinds of data. Because we see here, we can get better compression at a faster speed than the default of hdf5 with bitshuffle and LZ4, for example. And depending on your cases, you want to be fast or you want to compress a lot. So it's important to me to have many options. So a little side note, it's that since we provide the compiled plugins, it's also possible to use those outside of Python. If you get the path where those libraries are stored, you can get it from Python, and you can set the hdf5 plugin library. Then you can use it with another installation of hdf5. It's only for reading because in this case, you didn't link the plugin with the hdf5 library, so it won't be able to get information from hdf5 for compression. And about licenses, so hdf5 plugin is MIT code, but most of the code is not developed by us. It's the compression libraries and the compression filters, and they come with a lot of flavors of open source licenses. So before concluding, I just wanted to discuss a bit some shortcomings of current compression filter system in hdf5, in my opinion, compared to the libraries that are used underneath. And first one is that libraries like blosc or bitshuffle, because they want to fit in the CPU cache underneath, they are using a really small window, and you could access from those libraries directly uncompress some of those windows instead of uncompressing the whole hdf5 chunk. If I take an example, the dataset I had for the benchmark, it's one chunk per image, and if I want to access a small window in all images, I have to uncompress all the images, while underneath the compression works on 8K kilobyte smaller window, so you can only decompress those chunks. Also limitation in multi-threaded access, and in terms of distribution, there is a need for the plugin to get information about the data for compression to link with the hdf5 library, and that's a problem in Python because at compile time you don't know which library hdf5 you will use and where you will run. It's a conda environment. it's a Python install on the system, then you can have the plugins installed on the system, great. It's a virtual environment, you don't know which version of, anyway, you don't know which version and which library you will use ahead of time. And so since only gzip is available by default, you need to install something more to get more compressions. So of course there are solutions like direct chunk access. Instead of asking hdf5 to uncompress to do the compression, you can do it yourself and tell hdf5, here is what I compressed, put it in the file, or please give me the compressed chunk here and I will do it myself. So it's great, you can improve performances, you have lots more flexibility in what you can do, but at the expense of writing the code to do it, so that not all users can afford to do. And so in hdf5 plugin, what we do is, instead of linking to the hdf5 library, we provide a stub at compile time, and then we load dynamically the symbols from hdf5 to overcome this linking issue, which is working, but yeah, still a hack in my opinion. And finally, most of the compressions we provide are actually included in blosc or the new version blosc 2 for the DFP, for example. So, two questions. Why not providing an upgraded, newer version of the compression filters that takes into account the evolution of compression over time, like these small chunks that are used underneath by the compression filter? And what about having blosc 2 by default, because it provides many different trade-offs in terms of compressions. So that's it for my talk. Thanks for your attention. And you can find documentation, and source code is on GitHub. And I will thank all the contributors to hdf5 plugin, and also all the contributors to all embedded softwares inside this project, because it's a small layer on top of a lot of work from many people, the HDF group, and all the compression libraries and plugins that have been developed. Yeah, thanks for your attention.
Thank you, Thomas. Let's see if there is question in the chat.
I had a question from remote. This is Mark, he's optical. So thank you for the efforts. I really appreciated hdf5 plugins. It's definitely one of the easiest ways to distribute the plugins, although I think it is a little bit Python specific because of the hack that you mentioned, which I noticed works a little bit differently on Windows and other systems. I was wondering what you thought about governance of the plugin architecture, since they're usually small pieces of glue code that connect hdf5 to the underlying compressors, and not all of them, like the blosc plugin, are directly connected. For example, Zstandard is that plugin is written by an independent author, and not by, say, Facebook or Meta these days. So I'm wondering what your relationship is with the different plugin authors, and how do you manage that?
What is my relationship with the authors of the plugins, you mean?
Yes.
I didn't understand well all you said, so can you repeat just the main questions, and I will try to...
Yeah, so sorry, I was just thanking you mainly, but the main question is, how do you manage the relationship with the plugin authors, and what do you think about the state of governance over the plugins in general? It seems to be rather distributed, and there's not much central governance about who makes a certain plugin.
Okay, so yeah, because I'm in hdf5, we wanted to make it easy for the users, so we embed the code of the plugins in there. There is no Git submodules or no things. We fork the product, we copy paste the code there, but I don't want to make any changes to the code, not to create a fork of the filters, because then, I mean, yeah, there are small changes. I will be sure it will not change things, but over time, I don't want to create a different version of the same plugin, so we don't end up with incompatible filters in a way. So how I do this is, for now, I take one version of the plugin, put it into hdf5 plugin, and then when I have an issue, I submit a pull request to the upstream project. But the problem is that some projects like bitshuffle are responsive, some projects like LZ4 are less responsive, and some project as Zstandard. I think that it's you who made the pull request, right? Or some projects are not responsive. The guy is not maintaining it anymore. So in this case, that's an issue. But I wanted to discuss during this workshop with the HDF group because they have in the HDF group GitHub repository, there is this hdf5_plugin, which has many filters copied there. And I wanted to know if that might be a source of reference for maintained versions of the filters. But since there is no central repository where plugin author put their code, then it depends on the author of the filters.
Great, thank you.
Does that answer your?
Yes, and actually you got to the question I wanted to talk about as well with the HDF repository that you just referred to. So yeah, I would be very interested in seeing if that should be an authoritative reference, and that might be a way to work forward when we've lost contact with some of the original authors.
Yeah, I will be happy to rely on those because okay, yeah, I haven't tried the filters provided with again along the library. Library, I have to check that, but okay, for Mac, Windows, Linux, ARM, Intel, Power 9. Okay, yeah, then I have to check that. And yeah, because what I take as reference is the links that are in the, like you have a page with the hdf5 registered plugin, and I take the links there as the reference code. But some of those projects like Zstandard, they don't seem to be moving for years. So if you have a central repository or many that are maintained, I'd be happy to use that instead. Yeah. And to, yeah, definitely. Yeah, no, I wanted to spend more time on like making benchmarks, and well, I hadn't the time to do more. But so the data I showed compressed very well with like bitshuffle and LZ4 or whatever, I think, because it's lots of very small values. So then you end up with lots of zeros in the series. If you take, I tried with the tomography data, and which is more natural image-like kind of images. And there you have very poor compression unless you take some lossy approach. So it really depends on the kind of data that you want to compress, yes.
I think this one works. So Alexander here. Someone mentioned, I think Andy was talking about hdf5plugin and hdf5 and all that thing. Well, one issue, for example, that we work more on the cloud side of hdf5 have is that the filters, as you mentioned. So hdf5plugin is targeting hdf5 library. But for example, for HSDS, that's not really helpful because HSDS doesn't talk through the hdf5 library when it's working with the compressed data. So does hdf5plugin has any way that you actually can supply a buffer of, say, a chunk as a buffer, and that it will decompress and give us, decompressed data afterwards, or he has to go through the library there only?
No. hdf5plugin is meant to, to me, it's just a packaging effort of hdf5 filter to make them available from Python for reading and writing. It's, inside it, it's the hdf5 compression filters that it's the C binary of the compression of each compression filter. And it's just doing some dynamic loading of hdf5 sample for the plugins to work. But else, the core is the hdf5 compression filter that are used by the hdf5 library. And since HSDS is not using libhdf5, no, there is no chance to do this.
Okay.
I started playing with direct chunk read, and so doing the decompression myself from Python, and that would be more suited to HSDS because, this is what you get. You get the raw binary, a compressed blob in HSDS, and you want to do the decompression.
Yes, because someone mentioned ZAR. Well, they build their compression around num codecs package, and basically HSDS tends to use that one. And so there is a little misalignment, for example. And I think for ESRF there was, mention of bitshuffle.
Bitshuffle, yeah.
Yes, num codecs doesn't have it, but hdf5plugin has it, and so it's like a little. Yeah.
Okay, I think there are some that are easy because what the compression filter in hdf5 does is take the blob, give it to the library, and write what's come out of the library in the chunk, in the compressed chunk. And there, if you have the library accessible in Python, you can load this chunk and uncompress it directly. But like bitshuffle, it's adding a bit of a header at the beginning, and it's specific. It's not available, I guess, in numcodec. It's more they do it specifically. So in this case, you have to reverse engineer to do the same as the decompression is doing in the compression filter.
All right, thank you.
It's 10 lines of Python, but yeah. We still need to do it for each filter.
Thanks.